Hello, in this video I'm going to explain to you how to compress a trie. This is a visual explanation, and at the end I'm going to show you a pseudocode in English language, so you can start working on that if you already get to that point in the lab. It's very important that before watching this video you make sure you already read two documents. The first one is the additional information on Lab 18 about tries, so you can understand the representation with arrays I'm going to show you in the next slides. And it's also very important that you read additional information for Lab 18, but on the part of compressed tries, part 1, which is referred to the initial part of compressing a trie. So let's start. This is the array representation of a trie. So you can see here we have a trie that from the root has two branches, A and M. You go down here and you can see that you have one word which is up, because it finishes here, and you have another word which is apple, which finishes here. And then if you go to the next branch from the root, you have the word mom. So if you look at this trie, it will look something like that. So you have up, and here you have the finishing symbol for the word, and then the continuing of the word apple, and then mom. If we want to look the compressed trie representation of this, and that's why it's important that you have already read the part of additional information on compressed tries, you will see that it looks like that. Okay, so you have up here, and up continues to end of the word up or apple, and mom just finishes here. So this is the big picture. Now let's start to see how we compress the original trie. So what we do is we start by creating a new compressed trie, and then we are going to start up here at the very beginning, checking on the letters we have here. So we are going to start with the first letter, and we are going to store this letter in a variable that we call prefix, and we are going to check how many children this letter has. So we moved to the next level and we count how many non-null elements we have, and we only have one. So we can know now that A has only one child, so we can compress. So we compress, and we compress by adding P to the prefix, because this is a temporal storage of our compressed section of the trie. And next we move to the next array, and we again count how many children this one has by looking at here how many non-null elements we have, and we have only one, so we again compress. We move to the next level, and we see now that we have two children, so we cannot compress anymore. So the function finishes here. This is all the part that could be compressed, so we are going to insert it in our map. So we insert it in the map, calling, in the case of Java, you call the function put. In the case of C++, instead of put, you use insert here, and instead of a dot here, an arrow. So in this case, we have to insert a pair. So the first part of the pair is the prefix, so we are copying here. The problem is that the second part of the pair is a memory address to the next compressed trie, but we haven't built it yet, so we don't have a memory here. So to solve this problem, what we are going to do is to do a recursive call. So we are going to call again the function CompressTrie, starting at here. And after we finish that, we have built a new map, and then we will have the address, and we could point then to that new place. So let's see what happens when we call CompressTrie again. So we are going to be working in this part of the trie. So we do exactly the same with it as before. So we create a new compressed trie, and we start looking at the different letters we have here. So we start with the letter L, we put it here in prefix, and we are going to check how many children L has. So we get a pointer to the next level, count how many elements different from null we have here. We have only one, so we can compress. So we add the letter E to the prefix, and then we go to the next level. In the next level, we again have only one child, so we compressed, we add meaning the end of the word, and we go to the next level. In the next level, we hit null, and when we hit null, we are done. So we start copying here, we start copying this here, and we copy the content of prefix, but we again have the same problem here. So we are going now again recursively call CompressTrie with this part, and we call CompressTrie with child of the symbol signaling the end of the word. But as soon as we enter the function, we will get a null, a completely null array. So we just return null, and we are done with this part. So we go back to the end of to the beginning of the array and go for the next element. So we are here now. We count the number of, we put it in prefix, we count the number of children, it's null, we are done. So we copy this here, there we are, and to find out what address we have to put here, we make a recursive call using child, the symbol end of the word, and because we null try, we are going to get a null address. And now finally, we have finished building this map, and then we can return. So we return this CompressTrie to the original call, and then we can put a memory here pointing to that element. And then we can go back to the next element on this array, because we've starting with A, went all the way down until we complete the map, and then we move to the next one. So we move to the next one. Look at, we stored M in the prefix variable. We look at how many children M has. It has only one. We compressed. We add U to the prefix. We moved to the children of U to see how many children it has. It has only one. We compressed by adding M to the prefix. We moved to the children again. We see that it's only one child. We compressed. We move to it again. It's null, so we can insert it in the map. And now we have to find out the address, so we make a recursive call with child curly bracket. But because this is going to enter to the CompressTrie function as being a null trie, we just return null, and we are done. So these are the steps that you have to go through. You can hear, because CompressTrie is a recursive function, we have a base case here, we have a recursive call here. So the base case is, if your input trie is null, return null, that's it. Otherwise, create a new CompressTrie, and for each element in the very first array that is different from null, store the corresponding letter in the prefix, go to the next level, count the number of children. If this number is equal, add the letter to the prefix, move to the next level, and go to step 3 to 3. So you keep on counting while you have only one child. If you don't have one child at some point, you just finish compressing, so you add the pair with the recursive call. And after you have done all this for all the arrays in your trie, you return the CompressTrie. Thank you very much. I hope this helps you to go through the lab, and soon I'm going to explain to you the query method for CompressTries.